Hi everyone, this is Saideja from CSC. Today my topic is about random vectors. Let's get into our topic. Random vectors. An k-dimensional random vector is a function of x equal to. We can take the variables from x1 to up to a constant value taken as k dimension. We have taken the value from x1, x2, so on up to x power k. The whole transpose that associates a vector of real numbers with each element is a random variable. For example, a semiconductor chip is divided into m regions for the random experiment of finding the number of defects and their locations. Let ni donate the number of defects in ith region, then n equal to we have taken the values from n1 to so on up to n power m is a discrete random vector. And also in the random experiment of selecting a student's name, let h of I equal to height of the ith student in inches and weight of the student in pounds. Then s equal to height of the student to uh, height of the student and also weight of the student is a continuous random vector. Next, the another one is joint probability distribution. The joint probability distribution for random vector, we have taken two values x comma y. Transpose defines the probability of events defining in terms of both x and y. Joint cumulative distribution function for x equal to x comma y is given by f of x comma y equal to p of x less than of x or y less than of y. We have taken the 2 points of capital X and capital Y, and the distribute cumulative function have taken small x comma y. Then the p of x comma y equal to p of x less than small x, and the p of capital Y less than small y. We can see the graph how it was going on, the how the joint probability distribution occurs for the random vectors. Joint cumulative distribution function. We can see the joint cumulative function same as the function which we had taken before. For this, we have taken the values of x comma y, p of capital X less than small x or capital Y less than small y. The properties of joint cumulative distribution function is we have the few points and we can see the graph how it was going on the screen. We can see a few properties of joint cumulative distribution. So f of x comma y is non-decreasing in each variable, and also f of x comma y is continuous from the left in each variable. We can see it is continuous from left uh, on the graph from the left side to in each variable it was continuous, and also we can see the non-decreasing in each variable. Through the graph, we can observe these points. Discrete joint probability distributions. The probability function, also known as the probability mass function, for a joint probability distribution is defined as P of x of I comma y of j. We have taken the 2 points and then we convert into P of capital X equal to small x of I or capital Y equal to small y of j. And we can compare to before formula. We have taken the x of I and y of j as the discrete joint probability distributions. We can see the derivation how it was processed, and also we can see the probability mass function for the joint probability distribution. We can see, and also we have few properties of joint discrete probability distribution. uh, we can see through the table of joint probabilities. Here is a one of the type of problem. A random experiment consists of tossing coin of x and flipping die of y. Find probability mass function for a joint probability distribution of a random vector x comma y. We can see the table. Here we have to find the the p of 0 comma 1 and p of 1 comma 0, p of 3 comma 1, and also p of x less than 1 comma 3. Few more problems. Finding the probability mass function for a joint probability distribution of random vectors x comma y. Continuous joint probability distribution. We can see the continuous joint probability distribution formula where f of x comma y is a joint probability density function. Few more properties of joint probability density function. F of x comma y greater than or equal to 0 is the one of the property of joint probability density function. Finding the constant c so that f of x comma y is c of x plus y so on they can be joint probability density function of random vectors. That the function f of x comma y can be a joint probability density function of random vector x comma y. It has been satisfying condition. And here is the derivation of the joint probability density function. Next, the marginal probability distributions. Obtaining by summing or integrating the joint probability distribution over the values of other random variable. Discrete random vectors. We have the two types of random vectors in the marginal probability distribution. The first one is the discrete random vector and the another one is continuous random vector. In discrete random vector, we have taken the p of x of I and the continuous random vector we have taken f of x of I. You can see the problem. A random experiment consists of tossing coin x and flipping die of y. Probability mass function for a joint probability distribution of random vector. Finding the marginal probability mass function. We have to find the marginal probability of the given data and finding the function mass function. You can observe the table and how we calculated the mass function values by taking p of x of x of y and p of y of j values. Here is the calculated value of marginal probability mass function We can see through the bar graph. And here is the another problem. A certain farm produces two kinds of eggs on any given day, organic and non-organic. Let these two kinds of eggs be represented by the random variables x and y respectively. Given that the joint probability density function of these variables is given, and also the find the marginal density function. For this, we have taken the while integrating from the values, we have taken minus infinity to infinity because of we don't know the exact the density function, so we have taken the values from minus infinity to infinity. Here, the given table, we observe that have taken the values from 0 to 1, and we have derived the equation and finding the marginal density function. Here, conditional probability distributions. Conditional probability distributions arise from joint probability distributions, whereby we need to know that probability of one event given that the other event has happened. The random variables behind these events are joint, and here is also two types. One is a discrete random vector, and then the other one is continuous random vector. In the discrete random vector, p of y not equal to 0, and also in continuous random vector f of y not equal to 0. And also one more problem about the finding the joint and marginal probability distribution of a random vector. And also there is another problem, finding the density function. Condition for the density function we have taken, and also here is a formula for conditional density function. F of x by y equal to f of x comma y by f of y. With this formula, we are finding the density function. Conditional variance. Conditional variance is a variance of conditional probability distribution. Independence. Two random variables of x and y are independent if discrete random variables for all I comma j. We have taken p of x of I comma y of j is derived into p of x of I into x into p of y of I into y. And the another one is continuous random vector taken for all x comma y, f of x comma y equal to f of x into x and f of y equal to f of y into y. Measures of linear independence. Here is a few more measures of linear independence, covariance and correlation coefficients. A rho of x comma y is a scaled version of covariance. Covariance. Here is the covariance formula, and also finding the covariance matrix. So we have the few more topics is the covariance matrix and the correlation. And the next is the covariance rho of x comma y equal to covariance of x comma y by sigma of x into sigma of y. Then we are finding the correlation matrix. If rho of x comma y greater than 0, x comma y are positively correlated. If rho of x comma y less than 0, less than x comma y are negatively correlated. If rho of x comma y equal to 0, then x comma y are uncorrelated. Rho of x comma y belongs to minus 1 comma 1. And we can see the correlation, few more steps, and also the few more graph diagrams. Thank you all.